This is 7.7 acid rain. So today our goal is to describe acid deposition and describe the effects of acid deposition on the environment. So don't get concerned here, acid deposition is just a more broad term for acid rain, so it can include other types of precipitation, not just rain. So to accomplish this goal, we will describe the anthropogenic causes of acid deposition. So there are natural causes, but we're only going to focus on the man-made ones, and describe the effects of acid deposition on humans and the environment. So to begin, acid rain is a secondary pollutant itself. So remember that secondary pollutants are made from primary pollutants that undergo a reaction in the atmosphere. So we see that we have SOx and NOx. So as we learned in photochemical smog, the NOx is mostly from motor vehicles and coal-burning power plants. I gotta check myself because I keep writing PowerPoints, not power plants. And then the SOx is mostly just from the coal-burning plants. Oh, I almost did it there. Okay, so we've got NOx and SOx. So we see that the NOx and the SOx, which are emitted from the motor vehicles and the coal-burning power plants, enter into the atmosphere. They mix with water, and those things react together to create the acid rain. And we have two types of acid rain. We've got nitric acid and the sulfuric acid. So now that we got the basic process out of the way, let's look at what the issues are with acid rain. And the first is that acid rain is mostly the biggest problem for those that are downwind of the coal-burning power plants. So if this is our coal-burning power plant and you live over here, you are downwind of the coal-burning power plant, and you're going to suffer more of the acid rain effects. So probably the most well-known one is that it deteriorates man-made structures such as limestone. So we see here that this, the face here is almost completely gone. This is a statue in Germany. So the acid rain has eaten away at the limestone. It can damage tree leaves and needles. So if trees don't have leaves and needles, they're not performing photosynthesis as well. If they're not photosynthesizing, they're not strong and healthy and getting the food they need, and they could be more susceptible to diseases and drought, and ultimately it can kill off a lot of trees. And it also infiltrates or percolates into groundwater and can run off of our surface water. So we can see here's the process that leads to the tree death. So another issue is that the acid rain can lead to aluminum toxicity in plants. So this is plant suffering from aluminum toxicity. It damages the growth in the roots, so they start to look yellow and wilted. And it can also affect the overall availability of nutrients. So when the pH is too acidic, it makes the nutrients not able to be uptaken by the plant. It's important to know, additionally, that there's regional differences in our soil makeup and our bedrock that impacts how that acid deposition impacts our region. So we can see here the sensitivity of the bedrock to acid precipitation varies quite greatly across New England and Canada. So Connecticut, our sediments are low to medium in terms of how impacted they are by our bedrocks, low to medium impact from acid rain. What's interesting is that limestone has a unique ability to neutralize the effects of the acid rain. So it has a lot of calcium in it, which neutralizes acids. We read about this when we talked about acidic soils and what farmers could do if their soils were too acidic. They could add limestone into their soils to decrease the pH or increase the pH so it's less acidic. And what I thought was interesting is that West Virginia is fighting acid rain by dumping limestone straight into their streams. pH is important because it can cause the pH to go out of the critical range of which organisms can survive. So we have a bunch of different organisms here, such as snails. We all know I love snails. They have a critical pH level of 6. When it's outside of that level, their survivorship greatly decreases. So this goes back to what we discussed earlier about the range of tolerance. So the range of tolerance. So this can explain any abiotic factor like pH or temperature, or dissolved oxygen, or any nutrient in the water. So if we imagine that this is pH, this range of tolerance is the area that our organism is thriving and surviving. When we get outside of that, or too high, we get the physiological stress where we get less organisms, they reproduce less frequently because they're under stress, and then we get to our zone of intolerance where we have no organisms because it is, in this case, too acidic for them to survive. So to summarize, today we discussed the process of the creation of acid deposition and the effects of acid deposition on the environment. Acid deposition is formed from the combination of NOx and SOx and water. It leads to damaged man-made structures, damaged trees, and soil acidity, and we learned that limestone can be used to neutralize the acid in water.